This is another topic related to regression using time series data. When we have seasonal data, we may observe seasonality, which means the same pattern repeats itself every year. Now, if we want to run regression using seasonal data, apparently we do want to capture the seasonality. We do want to acknowledge that for each season, the pattern might be different. So the idea then is to hopefully create a separate regression line for each quarter, just like what we did in the last chapter when we talk about the dummy variables. We were creating regression line for female and male. There was an example about miles per gallon by drivers, by gender, and in that description, it seems like in the past there was statistics saying that women get higher miles per gallon than men drivers. Then we were using data to verify that. And in that scenario, we created different regression line for each gender. So we have the same idea here. If we have 4 quarters, then we want to ideally create different regression line for each quarter to represent the differences among the quarters. So let's get started actually with an example. Then we're gonna come back to this page for the theories, because I believe it's kind of easier for you to look at the actual data first, then come back and recognize, oh, okay, so that's how we capture the seasonality. So here's the example. At one time, James Brown, forecaster for Washington Water Power Company, wanted to forecast electrical usage for residential consumers for the third and fourth quarters of 1996. He knew the data was seasonal and decided to use regression to develop a forecasting equation. He used quarterly data from 1980 through the second quarter of 1996. The data for electrical usage are measured in millions of kilowatt hours. Estimate the equation and forecast for the third and fourth quarters of 1996. So actually in this example, we have a pure time series data in the sense that we only have one variable, which is the electrical usage, right? And it's going through time. And also it is quarterly data. The data file should be named Washington Water Power Company. So now I'm going to show you the data, and I'm going to share my Minitab screen. So let's take a look at the data. And here's usage. That's our main time series variable, right? It's quarterly data. There's one more variable created, which is T, represent the time. T goes from 1 to 66, meaning we have 66 observations in the data set, and they are in order. So apparently T will be our X variable, at least one of the X variables, and usage will be the Y variable. And to focus usage, we want to use time and see how usage change over time. We also want to capture the seasonality across different quarters. So we have another variable, which is quarter. Although we see numbers like 1, 2, 3, 4, but you should not interpret these as just the numbers you see usually, like the usage, because technically these quarters value are categories in the sense that we use 1 to represent the first quarter, we use 2 to represent the second quarter, etc. We cannot do the typical mathematical calculations. We can't say the fourth quarter is 4 times of the first quarter, although technically 4 is 4 times of 1. So we can't do the typical manipulation. We can't say the fourth quarter minus the third quarter. Okay, mathematically it is equal to 1. But if you use the fourth quarter minus the third quarter, that doesn't make any sense. You can't do mathematical calculations here with the quarters value. So we should regard them as categorical data. And therefore, for categorical data, we need to create dummy variables to represent each category. Recall from our discussion in chapter 7 that when we have k categories, we actually create k minus 1 dummy variables. That is, we do not create dummy variable for every category. Actually, we save one. We save one category as the omitted category. All right. So now let's go back to the theory and see how we structure the model, and then we're gonna go back to Minitab and carry out the analysis. So here's the theoretical model that we're gonna use to analyze the data. Y is still the dependent variable, which will be usage in our example. Beta 0 is the y-intercept, and beta 1 times t here is our first x variable, although we didn't use x specifically, but t can be interpreted as x1, right? And beta 1 is the slope coefficient. And by the way, t is the time variable that represents the progress in time, starting from 1 to 3 all the way to 66. Then you see 3 dummy variables out there to represent the 3 seasons. And we're going to do the last 3 seasons except for the first one. So S2 here represent the second quarter. S3 here, another dummy variable, represent the third quarter. S4 there represent the fourth quarter. And by the way, for dummy variables, they only take 2 values. Either is equal to 1 or to 0. Then the beta 2, beta 3, beta 4 are the slope coefficient for each of the seasonal dummies, right? And we have the specific explanation for each of the variables down here. And lastly, the epsilon is our typical error term, which is required to be independent and normally distributed. We can check that with our residual plots, right? The idea here is to use the data to estimate all the betas so that we have an equation to represent the usage, and then we can use the equation to forecast for the future usage, right? And notice that we only created 3 dummy variables because we only need 3. For the fourth one, which is actually the first quarter in our data, we're gonna designate that as the omitted category, and that can be represented by S2, S3, S4 all equal to 0, which means when all the dummy variables are taking value of 0, then that is the first quarter, right? So let's see, we're gonna go back to Minitab and see how we can run the regression model using dummy variables to get the results shown here. We're gonna come back to talk about the results and do further analysis. So let's move to Minitab. All right, here we go. Now, I know for the analysis, we can easily click several buttons to go through the analysis. Before that, I actually do want to type out the dummy variables that are created behind the scene within Minitab and then used in the regression, so that I hope this will help you to have a better idea of how dummy variables are created and used. So I'm gonna name this as S2, which is the season 2 dummy, S3 season 3 dummy, S4 season 4 dummy. Okay. So as we talk about it, season 2 represents the second season. It takes value of 1 if the observation is season 2. It takes value of 0 for all the other quarters. And therefore, I'm going to put 0 there because this is the first quarter. I will put 1 here because this is the second quarter, which is represented by S2. And then 0 again for the third quarter, 0 again for the fourth quarter. And I will repeat this pattern because this dummy variable only represents the second quarter. So whenever I see this observation belongs to the second quarter, I will give a value of 1. Otherwise, it's a value of 0. So that's the idea. Okay. Similarly, for S3 and S4, I'm going to give value of 0 to all other quarters except for the third quarter, which is right here. I put 1 there, and then 0 for the rest. 0, 0, oops, 0, 1, 0, right? For the last quarter, I'm gonna put 0 for the first 3 quarters and 1 for the last quarter. So that's the pattern of the dummy variable. All right, to kind of save time, I'm gonna just copy and paste these values to the rest of my dummy variables. so that I can create this dummy variable manually. And again, I know Minitab will create this behind the scene and run the regression, but the purpose is here is really to give you a better idea about the dummy variable and also how the dummy variable are used. So this is, so that's how the dummy variables are created. When we run regression, now we have two choices actually. The first choice is to ask Minitab to run the regression and take quarter as the categorical predictor. And the other option is actually to run multiple linear regression using uses as y and all of these as x variables. Let's try both. And theoretically speaking, we should get the same result. So let's give it a try. We're going to go to stat, regression again, fit regression model, and the response variable will be usage. Continuous predictor is t. And then let's do the categorical predictor within Minitab. So this will be quarter. Okay. We will be examining the residue. So let's take 41 here within graphs so that we can check it and click OK. All right. So here's the results we have, and we have categorical predictor coding, which is the typical 1-0 dummy variable. And we have 4 equations for each of the quarters. Then for prediction, we can use the corresponding regression line to forecast for the future. The coefficients, all of them are significant, right? So the p-value, all of the p-values are less than 5%, meaning all of them are significant. But we're going to come back to the quarter dummy variables later. Adjusted R-square 91%, which is good. F-test is also valid because p-value is virtually 0. Residues, I just glanced through. There's nothing that would make me concerned. Although you see here, when we look at the residues, in this scatter plot, we usually examine for heteroscedasticity, right? We look for the fan shaped. We don't see fan shape, but somehow you see the dots are clustered into 4. And this is really because we have seasonal data, we have 4 seasons. So actually these observations represent the 4 different quarters. And apparently 4 different quarters differentiate from each other. That's why we see them are clustered. But that's not a concern for us. And lastly, there's no specific pattern in the last plot. So we can say residuals are independent of each other. So that's the first method. Let's try the second method. Okay, we created our own dummy variable, which actually is the same as the one created within Minitab behind the scene. But this time I want to use P together with the 3 dummy variables I created to run the regression. So this time, you probably don't like it that much because you are given just one equation and you have to write your own equations for each quarter. It is not hard at all. It's just the other one give us directly. Although we only have one regression, what we can do is for the first quarter, we're going to put S2, S3, S4 all equal to 0. That gives us the first quarter equation, which is 968.4 plus 0.938 times t, which is exactly what we'll see here, right? The same equation. And for the second season, what you do is to give S2 equal to 1 and put the rest 2 equal to 0, which should be this second equation, the same equation there, if you go through the calculation, right? Now, in terms of coefficient, we actually got exactly the same values. You can do the comparison if you want to, but they are exactly the same. And same for R-squared, F-test, everything actually is the same. The only difference is that we use our own dummy variables created. We also only get one equation. So let's go back to the PowerPoint slides and go through the results in just a little bit more details. Especially, I want to focus on the dummy variables. All right. So the results shown here are the one that we used Minitab dummy variables. We got 4 equations. Now, I want to emphasize on the interpretation of the coefficients for the dummy variables, which is the quarter 2, 3, 4. The p-values, as I mentioned, less than 5%, meaning they are significant. But you need to know significant for what, right? For example, quarter 2, which is negative 341.9. What does it tell us? Well, actually, for each of the coefficient here, it shows the comparison of the corresponding quarter with the first quarter. Okay, so this negative 341.9 means the usage in that quarter is lower than the usage in the first quarter by 341.9. Okay, so that's how we interpret that. Same for the second coefficient, which is for quarter 3. It's negative 471.6. And that means the usage in the third quarter is lower than the usage in the first quarter by 471.6. And same for the last quarter, is still negative. So overall, what we can see is that the first quarter usage is always the highest in the year, which makes sense because it's the winter season, so we run our heat all the time, right? We've already mentioned the rest. One thing that we didn't pull out, but it's shown here, is the Durbin-Watson statistics. Since we just talked about it in the previous lecture, it wouldn't hurt for us to take a look. So DW statistic here is 1.47. Recall that for DW, if this is close to 2, that's the rule of thumb we have. If it's close to 2, then we don't have zero correlation problem, right? Now this number, I would say, is closer to 2 than to 0. So I'm going to conclude that zero correlation in residuals is not an issue in our regression model. And in particular, one reason is that although we're using time series data, we did use dummy variables to capture the seasonality. So to that extent, we kind of controlled for the time series flow there. That's why the Durbin-Watson statistic is not showing us any issues. All right, and the last slide we have is for forecast, because the question asks us to forecast for the next 2 quarters of 1996, right? So what we do is we can go back to Minitab. Let me do that. So we want to forecast for the next 2 quarters. If you pull all the way back, these are the 2 quarters. Quarter 3 and quarter 4 for 1996, okay? And the t-value for these 2 quarters should be 67 and 68. We need to know these values because that's what we put in the Minitab out here. I'm gonna rerun the previous models. All right, so this is the model we're gonna use for the prediction. Now pick predict. The first T should be 67, and that is the third quarter. And the second T is 68, and that's the fourth quarter of 1996, right? So click OK. There we go. Here's the results from Minitab. Now prediction Minitab combine everything together and give us one equation, which is the same equation we obtained when using the dummy variables we created ourselves. We're creating for 2 observations. This is the third quarter. Prediction is 559.65. And we have confidence interval, prediction interval, same for the fourth quarter, predicted to be 801, actually 8802. So that's about it. All right, same results I have here. And that's all we have for this chapter, and that's all we have for this lecture. Email me if you have any questions or concerns. Otherwise, I'll talk to you next time.